So let's start the BSD track with the status of FreeBSD when it comes to DRM and all of that. So Jean-Sébastien is going to talk about this.
Thank you. Hi, I'm going to present you the status of the graphic stack on FreeBSD. A quick word before I start. This is my first presentation at the conference, and English isn't my mother tongue, so I wrote down what I wanted to say so that I won't look for my words. I hope that's fine with you. I'm going to talk about the two major problems we have in FreeBSD, and for each of them, I'll describe what we are doing right now or planning to do. I'll continue with the impact they have on our relation with the community, you, and I will conclude with the future challenges once those issues are resolved. Throughout the presentation, I'm going to explain some concepts specific to FreeBSD, but if something is unclear for you, please interrupt me. So let's start with the kernel. Before the drivers were moved to the kernel, Linux, FreeBSD, and other operating systems shared a common DRM code base. In FreeBSD, this code was maintained by Eric and Holt here. Thank you. Then the KMS drivers arrived in Linux. At that time, FreeBSD was happy to continue with the old UMS driver, but at some point, newer hardware was only supported by the kernel driver. Intel GPUs were first, then Radeon. A quick note on NVIDIA, they provide their own driver for FreeBSD. That's why there was no pressure on this side. However, we were stuck with the Intel and Radeon drivers, GPUs. Thus, that's only when we had no choice that the FreeBSD Foundation sponsored Konstantin Belousov to port the Intel driver from Linux to FreeBSD, and that was in 2012. Konstantin Belousov was limited in time, so he decided to copy the original DRM code to a separate directory called DRM2. He then imported the Intel driver from Linux. I think it was Linux 3.2 or 3.4. I don't know exactly. The DRM device-independent code needed some work too, but instead of updating it, so taking it from Linux and porting it to FreeBSD again, he added the minimum features required by the Intel driver. He also replaced the Linux APIs and data structures, such as linked list, work queue, and so on, by the equivalent in FreeBSD. The next year, I wanted to help with the Radeon driver because I was using a barely working HD5000 card, and nobody was working on the driver at the time. Konstantin ported the TTM component in 15 days, and I ported the Radeon driver from, and both come from Linux 3.8. Again, I added the required missing features to DRM and used FreeBSD's APIs. That was my first contact with the graphic stack, so I didn't discuss the decisions at that time. Maybe a mistake. As you can see, the code was adapted to FreeBSD standards. Some variables were even renamed in the process. Obviously, this makes the import of new code from Linux very hard, or at least very time-consuming. Therefore, we need to work hard again to resync all the stack. Konstantin is about to commit an update to the Intel driver so that we gain as well support. Meanwhile, I worked on syncing the DRM device-independent code to Linux 3.8. So now the complete code, not just portion of it. But that's not enough if we want to catch up. For instance, there was no update to the Intel driver in the past 2 years. I plan to use a Linux API wrapper. This should spare us from changing every single line and deeply ease the maintenance. But I still need to convince other developers. I hope I will succeed, otherwise we are in troubles. Besides, I'd like to do what François Tigeot already did in Dragonfly BSD. He merged the original DRM directory and its copy, the DRM2 directory. As you can imagine, we are still months away from a state where we can easily import code from Linux to FreeBSD. So that was the major problem we have in the kernel. Now the port tree. I will start with a brief introduction in case people don't know exactly what the port tree is. So the port tree is our way to package third-party applications. The tree consists of makefile and patches. That's the equivalent of the Debian directory on Debian or the spec file with RPM. Here is an example of how to install an application. You enter the port directory, here the X.Org server, and you just run make or install clean. This will fetch the source archive of the X.Org server, build it and install it. If you don't want to install the application and the host, but prefer a package to deploy elsewhere, run make package instead of make install. That's a low-level approach to show you how it works. There are higher-level, more user-friendly tools to manage ports. The ports tree has a very nice feature. It supports all releases of FreeBSD. That means all releases have access to the latest application, no matter which version of FreeBSD you run. For instance, a case I had at work, PHP 5.4 is available on any FreeBSD, unlike, for instance, Debian, where you need to use third-party repository or move to a newer version. So that's nice, but this has disadvantages. For instance, a package must handle missing features in older releases. Regarding the distribution of these packages, the user historically fetches the ports tree and uses it as shown in the previous example. But for a year, we moved to binary packages as first-class citizen. Of course, this requires many changes in the ports tree itself because it's used to build the binary packages. But more importantly, changes in developers and users' habits. The new system is young, and the binary system is young, and we still miss very useful features. The most important for us, the graphics team, is the lack of a provides-like mechanism as found in many packages system. I just reuse, but provides is the name used in Debian. Okay, let me sum up what I said earlier about FreeBSD releases and what they support in the following table. FreeBSD 8 has no KMS drivers at all, and it's still supported until June 2015. FreeBSD 9 gained first the Intel drivers, then the Radeon driver. FreeBSD 10.0 has the same drivers than FreeBSD 9.3. And finally, FreeBSD 10.1, which is about to be released in maybe a month, brings hardware context support to the Intel driver, a feature expected by Mesa 9.2. The second table shows which X component we can use on which FreeBSD release. FreeBSD 8 is limited to X Server 1.7 and only UMS-aware DDX. Starting with FreeBSD 9, X Server 1.12 and the KMS-aware DDX can be used. However, we are limited to Mesa 9.1 because the Intel driver doesn't have hardware context. Finally, FreeBSD 10.1 will support Mesa 9.2 and later versions. As you can see, the port tree needs to support all releases from FreeBSD 8 to 10.1. However, due to the lack of provides, multiple versions of X Server or Mesa can coexist. To work around this, we implemented something we call with new X.Org. This is a build time flag in the port tree. It allows the user or the package building machine to choose between two sets, either the old stack, comprised of X Server 1.7 and Mesa 7.6, or the new stack, which isn't new anymore, X Server 1.12 and Mesa 9.1. I suppose you noticed how broken it is. First, it's unsuitable for binary packages because FreeBSD 9.0 and 9.3 have different levels of support, but they use the same repository. Second, this binds X Server and Mesa together, and this is very wrong. Besides, Mesa 10 works way better on Radeon than 9.1, but we can use Mesa 10 with our Intel driver, except on FreeBSD 10.1. And the flag, the with new X.Org flag, doesn't allow to select a specific Mesa version. Third, this is obviously a nightmare to maintain and to test. That's why we don't update applications. Fourth, from the end user's point of view, this is very confusing too. They don't understand why they have to rebuild packages with this flag or set up an alternative binary package repository. Unfortunately, this is the only solution until the provide feature is implemented. But at last, we convinced people recently that this solution was making more damages than it was resolving problems. The recent update to Kero, we updated to Kero 1.12, which broke X for Intel UMS users, was ridiculous enough to make everybody accept to use the new stack everywhere and start to drop the old one. Now, I'm going to talk about the impact those two issues had on our relation with the community. We are a small team. We are 4 people to work on the graphic stack. And some of us work on other areas in FreeBSD too. And we all work on our spare time. Furthermore, we still need to learn the ways of the graphic stack to gain confidence and do a better job. In fact, people, including us, are afraid of changes because of these technical problems I described, and because of our limited time and knowledge. Thus, updates to the graphic stack are infrequent, large, and risky. Furthermore, we don't take time to clearly explain what we do and why, like why the video drivers are moved to the kernel. This confuses our user. This example explains why they don't trust this KMS thing and believe that's the wrong direction. After all, everything was working nicely so far on their point of view. Last but not least, because we are only consuming, we never talk to you and contribute back. To solve this, we already increased our presence on mailing list and IRC. We reworked our wiki section with up-to-date information and published more detailed quarterly status reports. We need to continue on that path. We must improve bug reports handling and broaden our publications, at least with, I think, frequent blog posts. And above all, we must teach the user, guide him for him to trust us again. I want to conclude with the challenges ahead of us, challenges we can tackle without resolving all the problems mentioned above. Personally, on the KMS driver, I want to finish the sync of DRM and drivers with Linux 3.8 so that the whole component correspond to the same Linux version. This will allow us to update atomically to a later version the device-independent code and the drivers. We need to work on DRM Prime too, as well as Nouveau as time permits. On the GPU side, we are not finished with the alternative to UDEV required by Mesa, as well as the packaging. But for now, small OpenCL programs are currently working, at least on the Radeon driver. Now on the X server without the root privileges, we have to study what is required from the OS. I didn't look at it yet. On the Wayland and Western side, I think the most important part is evdev and libinput. GSOC students implemented evdev this year. It needs to be reviewed and imported into the kernel. And of course, probably one of the most important challenges is to work with you all again. So the best place to find information about our roadmap and ways to contact us is our wiki section, available at wiki.freebsd.org/graphics with a capital G. Okay, I covered our major problems and what we are doing to solve them. So, do you have any questions?
So, given the ports tree is compile time based, I don't understand why it can't discover from the system what version of the kernel it's sitting on top. Why does it need the with new X.Org?
Oh, it can discover when you build on the host, but as we want to move to binary packages, we don't know what the user uses as his desktop. And this is the same repository for FreeBSD 9, 9.1, 9.2, and 9.3. This is a single repository.
You need the binary packages to work across all those releases as well. So that's
at least in the same branch.
It's a very alien concept.
Sorry?
It's a very alien concept, the idea that the binary packages are not tied to the version of the distribution.
It's tied to the branch. So there is one repository for the 9 branch, one for the 10 branch, but it's expected that something that works on 9.1 will work on 9.3. And in fact, we try to keep the compatibility inside, the ABI compatibility inside the branch. So that's why we only need one repository for the whole branch.
Okay.
But yeah, our kernels have different level of support of the drivers, so we are screwed.
Yes, it's not really a question, but I know for the systemd login problem, I know the OpenBSD guys have worked on a project which name is SystemBSD, which is a wrapper for the API. So maybe it's a way to start.
Yeah, probably. I heard about that project too, but didn't have the time yet to look at it.
Just to give in.
Thank you.
Okay, this isn't a question either. It's just a comment. Just want to say I think that what you're doing now is absolutely right. just talking back, telling people what problems you have so they notice that you exist. And I mean, I'm sure everyone understands you don't have time to contribute masses of code. So I think even if they just know you're there, you have these problems, that will do you a lot of good. So.
Yeah, I think so. That's the goal of our presence here, to show that we still care about the graphics stack. And we want to contribute back.
So I don't know about the other BSDs, but in NetBSD, this kind of support was recently added by Taylor Campbell. I don't know if you looked at it, because the way he did it was to actually write a layer of emulation for the Linux APIs. So that's what you are saying you would like to convince other people to do with you. So maybe you can take it as an example. I don't know what the other BSDs do. Maybe they do it also. So you should look at the competition and maybe grab the code, because it's free.
I won't spoil the next talk, but in fact, we already have that kind of shim. One is used in the InfiniBand driver. But the Konstantin Belousov, the original author of the Linux Intel driver port, preferred to use FreeBSD's API. But so it's a great goal, but it doesn't scale. We are only 2 people in the kernel side. So at some point we need to make some decision and move forward.
Yeah, I'll talk about this stuff in a bit, but speaking specifically about NetBSD, they're very late to the party, and I don't think they have something working yet. So, well, I just spoke to Taylor 2 weeks ago, and he told me they started to have something, but it was not completely working yet. So. Okay. Yeah, indeed, I think, I also think they made the right choices.
That's good news.
I'll probably talk about it later. Any more questions?
Okay, so thank you.
Thank you. Thank you.